Well, hello everyone and welcome to another video from the Canal Sidings Model Railway channel. A bit late after the last one, which was actually published in 2018 between Christmas and New Year. I have been hard at work producing items for model railways, but none of them really have been worth putting on a video up to now. I've also started the tear down of the old Inglethwaite layout, ready for starting the new one, and all the preliminary work that I've been doing out of this room, because this is my railway room, and it gets pretty cold in here in the winter. Despite the fact it has heated, it has a radiator, it's not really enough. It has a flat roof and it cools down very quickly. So I've actually been in the lounge at home with my table, and I've been doing odds and ends of things, which I'll mention sort of in passing briefly at the end of the video. And you can comment on those and decide whether or not you want to see more about them if you wish. I will be asking that everybody who watches this video, who does actually build model railways, and I know there are probably a few of you who don't, but everybody who does build model railways, I'd like you to comment, and I'll tell you what I want you to comment on towards the end of the video, once I've shown you where we are. Now, as you've probably seen, the title of this video indicates that it's part 3 of our servo mount for point operation, and the first two videos showed the first two iterations of that, and they were dated March 2018, video number 47, that was part 1, and April 2018, which was part 2, video number 51. So if you want to go and look at those to see where all this started, you can. What this one is, it shows the iterations of the design that we have had since those dates, and also what we now consider to be the final version. So I shall get on with it and show you what we were doing. So the next iteration after the ones that you see in those videos of 2018 was this. Now, what inspired this massive change, if you look at the old one, I haven't got one of the old ones, unfortunately. We took them all apart to salvage all the bits because we were running out of parts. But the old one used to use a cam, which, if you can see that cam there, there's a cam that runs on the servo horn here that operates the micro switches, and the micro switches used to be under the cam, under there. And when we put two micro switches on the same cam, there was a tendency for the whole thing, can I show you this, to lift. The servo horn can actually move. It's not the servo horn that's moving, it's bending. And I did have an instance where two micro switches that I tried, the servo horn, after it had been sitting over the micro switches for a while, had actually, the servo horn had been bent by the pressure of the micro switches just enough for one of them to stop working. So that was a potential failure for any point system. So what happened here was the servo was completely redesigned, sorry, the cam was completely redesigned in order that it didn't push upwards on here, it pushed in that direction, downwards, so that it could operate as many micro switches as you like, excuse me. Now, this one failed to meet the grade on a couple of reasons. The first reason is that it's too wide. It's much wider than the other one. but it was a proof of concept. The second way it failed is that this is all too loose. That isn't spring, that is just the wire moving. Part of it is due to the wire. I can hold it still and point to it there. The wire is moving in the servo horn, and part of it is the wire moving between these two adjustable stops which form the fulcrum, and you can move them up and down as we said in the last video. All that slack just meant that things were worse in respect of the rise and fall of this as it bends and twists going through the point. Remember from the last video we were a little bit concerned about the rise and fall of the wire, which you can see if we push that right round there, that wire's come up quite high. I don't know if you can actually see that. And as I move the servo this way, oh, I've gone past the micro switch now. Okay, another problem. As we come back down here, the servo, the wire rises and falls. Not a very good demonstration, very hard to operate. But that one was rejected on those grounds. So, we then did the version 4. That was version 3. We then did version 4, which is a radical departure from that system. In order to reduce the slack, we now don't mount the wire in the servo horn. If you can have a good look at this, there's your servo, micro switches either side, yeah, and this turns, and that is the cam now. The cam operates the micro switches, and up here, this screw at the top, the wire runs through the slot in its head, and that is what moves the wire. Again, a proof of concept, and the wire is solid at the bottom here. So all of the movement of the servo moves the wire, and you can see there's no slack. That is all spring. This actually could almost have been the last iteration, but for two problems. The first problem is not a showstopper, but to make it more of a commercial proposition, we wanted to allow people to use other than 0.6mm wire. And Hugo did find when he was doing some experiments that on pico points, if you insist on leaving the over centre spring in, then the 0.6mm wire is always going to be a problem to you, because it just can't always push against the pressure of that over centre spring. Yeah, not something I'd ever thought about, because for servo operated points I always remove the over centre spring in the pico points. Anyway, so because it goes through the slot of that screw, the 0.6mm wire fits perfectly. But how do we allow for the people who want slightly thicker, 0.8 being the next one up, which is pretty good. Still got plenty of spring in it, but will still operate the points. And even the people who must use 1mm. It does seem that 1mm has become the norm. Merg's servo mounts for points all use 1mm wire, and I have realised recently that that is a lot to do with all the ticking of the points. When the servo gets to the end, it's straining to bend the 1mm wire, which is virtually impossible for it to do. And so you hear this humming noise as the servo repeatedly tries to move into the position it's been asked to go to. And perfect adjustment never quite removes it, because it makes it very loose at the ends of the travel if you adjust it so that it doesn't tick. And just to get that little bit of pressure, it ticks. It's helped by turning the servo drive off, but it still sounds pretty awful until the drive turns off half a second or so after the movement is finished. So I have found that by using the thinner wire, all that problem goes away. The servos rarely make any sound at all unless you're really overdriving them, and that's never necessary. So that's why we want to allow for smaller wire. The people who want to use 1mm, we still want to allow to do it, because they will have their reasons, and we're not here to dictate to anybody what they should be able to do. The other failing of this mount is a showstopper, in that they are the mounting holes, and the expectation is that you will put screws in. Let me get my pointer up there. You can't get to them. You can move that all the way to that side and you can just about get to that hole, but the microswitch is in danger of being destroyed. It's just really not a viable design. So I'm afraid that one went out of the window, but it has proven that this system, with the wire solidly anchored here and the wire running in something there where that screw can actually run up and down the wire, so we've almost converted this rotary movement into a linear one, which is, after all, what a lot of people have tried to do in the past. But we've done it and managed to maintain a good spring in the wire, and a small footprint with 3 microswitches. The microswitches are not adjustable because they work at the ends of travel. I can't even hear them. It's very hard to turn this one. There we go. Put it back to the centre. Okay. So the microswitches are still not adjustable and haven't given us any problems. So this forms the basis of what we're going to call the final version. So what I'll do now is I'll show you the parts for the final version. Get rid of that. And here they are. There are 4 parts involved. There's first of all the mount. The servo goes in here. So now you mount it up beside the servo. So if you look at that mount, that seems to go that way round, but this one is this way round now. There is also this piece that goes on the bottom, because you can't print. I think it goes there. You can't print now up that way and up that way. There's nowhere to stand it while it prints. It's a 3D printing problem. When we put it to shapeways, I think that goes there. I think it goes there. When we put it to shapeways, then shapeways don't have any such problem, so that will be part of the design. Actually, it probably goes there. I can't remember which side it goes. It's obvious when you put the servo in. And also we have the cam, where we sit it over the point, over the servo. The wire comes up through here and goes between the cam and this bridge piece that goes across the cam. If I can get it to sit there. And got it the wrong way round. As always, wrong way round. It's very similar to that one. No, it is the right way round. I'm not an expert at this yet, but essentially it goes that way. That's why I've got it wrong. It goes there, like that. Okay, sorry about that. It goes that way round. So you have the slot there for the wire to come through. The servo horn is actually fitted across here in these holes and is bolted through there. It's hard to see, but you'll see it when it's built. And for the pivot, instead of a screw, what this uses is a piece of PTFE tubing. Yeah, PTFE tubing that actually sits in there and goes through this piece as well. Goes through that piece and through that piece. I'm not showing this very well because it is quite difficult and everything's white, so it doesn't show up too well. But essentially the wire goes up from there through here and through the PTFE sleeving, which is cross drilled to take the wire, so the wire will always be the right size. You'll drill it the size of your wire, and then it comes up from here past the top here and into through the baseboard. You'll see it when I'm sorry, not through here, up here. The servo sitting here, up here and into the baseboard. It's very similar in concept to this one, but not identical. So what I'll do is I'll show you a built one of these, which is actually mounted on a baseboard underneath a point, and we'll make it operate. Move those bits out of the way. And here we have the built version. Oops. It's upside down at the moment, the wire's coming through here, operating the point, and hopefully you can see that the wire goes through this piece of PTFE tube here. It actually is cross-drilled through it, so that as that moves, and I should be able to move it like that, you see the piece of PTFE tubing rotates, and get it a bit closer for you. Try and hold it up a bit higher. The piece of PTFE tubing rotates, and because it's PTFE, it's a very smooth rotation. There's almost no rise and fall on the wire. As you can see, the wire is operating the point. You can see it spring loaded at both ends, but no rise and fall to speak of. So we have actually achieved everything, and you can see the point operating. I'll turn that round. I can hear the micro switch click every time as well. Only one click because I've only got one micro switch mounted. There are two more and they operate at the ends of travel, or almost at the ends of travel. So, let me just stand that on. So there you have what we consider the final version of our point actuator, and of course we needed a name for it. And while we were talking, this piece was called the bridge, and it fits over the cam. So the nickname immediately came to both of us. It's got to be the Cam Bridge, hasn't it? Or the Cambridge. As both of us live in Cambridgeshire, it's become the Cambridge Turnout actuator. And we now call it CTA. So, because you've got to have a three-letter acronym for everything. So it's the Cambridge Turnout actuator, henceforth known as CTA. It has met most of the criteria that I came up with in the first instance, bar one. In fact, it's met everything bar one. And that one thing it hasn't met is that it is not completely without need for adjustment. And this is something we learned is actually impossible. As we've gone through this, and as I've played a lot more with these servos, I have realised that these cheap servos, and here is the one that we actually are going to use probably, which is the Hobby King, and that's the actuator, the horn that you use on it, and that's what goes through here and gets bolted to it. It's very hard for me to hold it and show you, but as you can see, you can just see the servo horn there. We've cut the ends off of it. I think they do need cutting off for some reason, but they just snip off after you've fitted it. It's very easy. And there's this type of servo, and there's this type of servo. This is the Tower Pro, get it in the picture, this is the Tower Pro 9G servo, the SG90, and this is the Hobby King 10G servo, which is the 17185, 17158, 15178. I think that's what it says. I think it says 15178. I'll read that again. It is the 15178. Yeah, that is the part. That is from Hobby King. Now, these used to be dirt cheap. Let me just get in the picture. This is in my way, that's why I'm not getting things in the picture again. These used to be dirt cheap, the Tower Pros. We've had a few fail while we've been doing this, and what seems to have failed on them in most cases is the position sensing potentiometer. It has just given up and gone noisy and made the servo click round almost. These we haven't had a problem with. We have, Hugo has done some life testing on, not that one, but on one, with the Tower Pro servos, and he's never managed to even make a dent in the wear on these. They just don't wear. But after 10,000 operations, an operation being open, close, after 10,000 of those, the first Tower Pro servo failed. It became incredibly noisy and eventually stopped working. He did another run with a second Tower Pro at a slightly slower speed. He was going really fast to try and get the whole thing over with quickly, the test over with quickly. For some reason the postman has just rang the doorbell. That's what that sound was. But he managed to get another one to run for 30,000 operations, and again there was no sign of any wear on the CTA. So we're happy that that is a good design. The servos are open to debate, but it did do 30,000. These we think are a better quality servo and will do more than 30,000, but we haven't done a life test on one yet. What we have done, what we have found is that these you used to be able to buy very cheaply. For some reason you now can't get them that cheaply, whereas the Hobby King servos are presently selling for £1.84, and the ones that I've just bought were £1.84 and sourced from the UK. When you buy direct from Hobby King, what you will find is that sometimes they're out of stock in the UK, and then you do have a long wait to get them from China. You know, several weeks, couple of weeks wait. But just bear in mind that that's what you have to do. To get these at anything sensible price, you've got to import them from China anyway. So bear in mind that they are a bit, could be on a longish lead time. But what we've found with both types of servo is that their positional accuracy, given that the specification for them is a 90-degree travel through the centre point of the servo, and that 90-degree travel between 1 and 2 milliseconds of pulse width, which should put the 90-degree point at 1.5 milliseconds, that is very variable on these servos. The Hobby Kings are no different to these. I found that Hobby King tend to move a slightly shorter than 90-degree distance, from 1 to 2 milliseconds, whereas these tend to just about manage it. So to be able to put a servo on something, and their centre point isn't very accurate either. The 90-degree point is often not at 1.5 milliseconds. I've found it to be as much as 10 or 20% out. So that requirement of not having to adjust the servo just isn't going to happen. No one is going to produce something where you can't adjust the servo. But generally speaking, whatever you drive the servo with is going to have an adjustment which you do not have to fiddle about with underneath to do it. You do it by adjusting the pulse width that you put down that cable for a given position. So what I expect there is that it will be relatively easy whatever you use. If you use mega points, you use a couple of push buttons and you adjust it to the max and min values you want. If you use the Merg kits, then you use well, if you use a Servo 4, you use the servo set, or you use the PC utility. If you use a Can Mio from Servo, or a Can Servo as it should call it, I don't know because I haven't got one and I've not tried. I've not read the instructions, but I would imagine that you do very similar things. Now, the question of, can you guys get hold of these so that you can make your own and use our Cambridge Turnout actuator? We have priced this up on Shapeways, whereby this piece and this piece will be one piece, and you'll just get those, so there'll be 3 pieces. We have priced it up along with one of those, which is a template which helps you cut and cross drill this. You push that in, you throw that on the floor, sorry about that, I'll try again. You push the PTFE tube into there, it's got a burr on that end, like that. Oh dear, I'm really struggling with this PTFE tubing today. There we go, it's in now. You push that all the way to the bottom, and then you just use a knife and cut it off. You then cross drill it. You go to the bottom of there with your drill, whatever size you want, 0.6, 0.8, 1 millimetre. You cross drill it, and then with your drill you pull it back out again. Yeah, and then you fit it in there. You then set your point up. Without this is not here. You set your point up where you want it on your baseboard. You've got no wire in it. You space the point blades with what I use is about 30 thou plastic card. Just a piece each side is perfect for pico points. That holds it dead centre, and then you put a drill. I just mark it with a 1 millimetre drill. I just mark the top of the baseboard. Then you remove the point and you drill through the centre of that mark with a drill that is just the right size for your wire. You then push a piece of wire through the baseboard and open this hole out to what your wire size is. Mine is 0.6, so it fits over 0.6 wire. Can't find the hole, but there it is. So it fits over 0.6 wire. So you've now got that positioned exactly where it should be now. When the point was on the baseboard, what you needed to do was just mark where the stock rails are. You just go either side of the point. I can't hold this. Just mark where the stock rails are, so that when you put this back down, you can put it where the marks in the stock rails are. Then you can drill through the mounting holes. They're deliberately small so that you can put a small drill through, and then you can put whatever size screws you want through these holes to mount it. That's something that we're still thinking about and working on, but the idea is you'll probably get one of these with every pair of those from Shapeways. Now we come to the dodgy bit, the cost. We're a little surprised at how much that pair is going to cost when made by Shapeways. It's looking like £15 a pair. That's £7.50 each. Now, at first we thought that was expensive until we looked at some of the other mounts that are available. There's one called the Dingo Servo mount, which is available in the UK. Just go to Dingo Servo. Just look up Dingo Servo mount, you'll find it. That's an aluminium job, much bigger than this, much bigger, and uses a linear motion from the rotation of the servo. They cost £7.50, not including the servo, but do have all the screws with them, and they do come with 2 micro switches. But their micro switch adjustment is just as bad as everybody else's. It has to be done once the servo has moved the point, and basically the servo pushes against the micro switch, and if it overdrives it crashes into the micro switch. So that's why it has to be adjusted afterwards. So that suffers from one of the problems that I couldn't handle, which was adjustable micro switches. But that is the cheapest one that we found, the Dingo Servo mount, the cheapest one that actually does the job. There are others out there, but they're just brackets to hold servos, they're not the same. No micro switches, etc. Then you've got the likes of oh, there's another one which I've forgotten. Anyway, you've got this one, which is £7.50 for those parts. To that you will need to add as many micro switches as you need for each one, the wire, and 2 M2 bolts, 10mm with nuts on, and 2 M2 10mm bolts per servo, no nuts required. Sorry, per micro switch, no nuts required. And then whatever you're going to mount on here. So not really many other parts, and of course your servo. So that probably puts the price at about £10, because the servo is going to cost you just under £2, £7.50 for that, actually £9.50, plus the other bits taking you to just about £10. Okay, the micro switches might be a little more expensive. They're not that expensive. Depends how many you buy and where you buy them from again. I haven't yet looked to see if I can find a Far Eastern source of those micro switches, but they're zippy switches. So well, let's talk around £10 plus the cost of more than one micro switch. And then of course you've got your cobalts and your tortoises up at a more like £15–16 each. And now we come to what I want you to comment on, and I'd like everybody who watches this video to comment whether you intend to use that or not. You all use something to operate your points. Whether you intend to use our servo mount or not doesn't matter. We'd like your opinion and a statement as to, if you needed them, would you pay that price? This is what we want to know. If there isn't sufficient interest, then we won't put it on Shapeways, because it's just not worth the effort of the extra engineering involved. But what we're looking for is interest, not commitment, not to say we'll buy it and here's our money. just the interest. So please, everybody who's watched it, whether or not you want any of these, let us know what you think about the cost. Bearing in mind that it is a properly engineered solution, does not require any adjustment of the microswitches, can take up to 3 microswitches, 2 of which are at the ends of travel, so can be used for route proving. I've set my route now, are all the points in the right position? Or they can be used to simply drive lamps. You probably only need one at the end to drive your lamp on your control panel to say points this way or points the other way. And you've got your centre one, which you can control your polarity of your crossing V. So please do comment on that. Don't care if you say nothing more than what you think of the price and whether you would buy at that price were you in the market. That's all we want to know. So thanks for that. We're going to try and use the power of YouTube to actually find out whether what we're doing is worthwhile. It's certainly worthwhile to me. I will be using it. But I won't be using the Shapeways version. As one of the co-inventors, I'm going to have 3D printed. I've already got the first batch of 3D printed ones that I can play with. So that really is it. What else have I been doing which has kept me back from doing all this? Well, one thing, I'll just pop in another bit of video, was this, which sits outside my room where I do most of my videos and warns people who come into the utility room that I am actually doing a video, because I've had all sorts of people come in through the door or my wife go and start the washing machine or say, "Are you recording?" which of course means that I'm immediately stopped. So I built that. That uses an Arduino Pro Mini that I just happen to have in stock, and a set of 8 8x8 LED matrix system boards and an arrays, LED arrays. I just switch it on and it flashes until I switch it off. So that's one thing that I spent about a week doing, making the case, cutting out the front, sourcing all the parts. It cost me about £15. It wasn't cheap, but most of that price, I think it was nearly £7 for the box. And then the LED matrices were about £6 for 2. That gave me the 8. And there's the Nano and a couple of other ancillary bits and pieces, plus a 5-volt power supply, because it runs at about 200 milliamps. So you can't just use a battery for it. It needs a bit more than that. So that's one thing I've been doing. Another thing I've been doing is, if you remember my last video, or the one before, no, not the last one was a final running session on Inglethwaite. My last video before that was one on a DCC accessory decoder for megapoints, where I had intended to use a megapoints module from Merg, so it was a kit. And I probably needed about 3 of them for Inglethwaite, which would be 30 quid each for the megapoints controller. And if I'd bought a Merg accessory decoder, sorry, not a Merg, a megapoints accessory decoder, it would have cost me another 30 quid each for those, and each one can only drive 1 megapoints board. So that was going to be about what was it, 180 quid. And when I blew up my megapoints board, my Merg megapoints, my fault entirely, while I was waiting to get the replacement IC for it from Merg, which actually took far longer than it should have done, due to somebody actually forgetting to that I'd even contacted. Anyway, that focused my attentions, and what I actually did was this. This is just a photograph of what's going on in my lounge at the moment. That is an Arduino Nano plugged into an expansion board, which conveniently has 3-pin connectors providing power and ground and signal on every Arduino pin. So I simply plug the servos straight into there, having cut a couple of tracks to allow me to have a separate 5-volt servo supply, which is what that little IC at the other end of the breadboard is. That is a, in my case, 12-volt in, 5-volt out buck regulator. It's a switch mode power supply, so it's very efficient, runs at about 90%, and gives me 5 volts at up to 3 amps to drive the servos. And then the little IC, the little black 8-pin IC in the middle, is an opto isolator that takes in the DCC track voltage and isolates it and turns it into a 5-volt logic signal, which drives an Arduino input pin, so that we can actually read the accessory commands and use them to move the servos to change the points. Now, the cost of those bits, I have a collage that I've printed. The cost of those parts is written on here. Let me just get this so that you can see it. Hang on, I'll get there in a minute. I'm not good at this. I can't seem to get it in the picture. There we go. Right. What you've got is the big red board is the breakout board. As you can see, it costs £1.37 each. The Arduino Nano sat there at £1.72, I think that says. The little power supply at 78 pence, and then a little board to mount the power supply and that little IC on, which cost about 13p. Total £4.27, and that will drive 12 servos from a DCC accessory. Sorry, from the DCC track voltage. I'll put that down now. I only bought those in quantities of 10. Those parts, I bought 10 of everything, and they were the prices I paid for 10 each, 10 off of each. They all came from China, some via Amazon, some via eBay, and I have a working system. Unlike Megapoints, you do need a PC to set it up, and you plug the PC into the USB port on the Arduino Nano, and then you send commands to it, things like S-Max sets the selected servo maximum angle to an angle, and S-Min sets the other end. You can nudge it up and down by using the left and right bracket keys, either shifted or not, to determine whether you go further away or closer. And you can look at what the settings of any given servo are by using SDAT space and the servo number. The servos are numbered 1 to 12. You don't have to fit all of them. If you leave a space, then that servo will just not be, it just isn't there. They're all allowed for, but it just won't be there. You can set the base accessory address to whatever you like within reason, so it can be anything from accessory address 1 to 2033, because 2044 being the highest one, you can't set it any higher, otherwise the top servo or servos will be outside the accessory address range. But it's quite a big chunk of code. It compiles on the Arduino to almost 20 kilobytes now, But anybody who's interested in that, then I can make the software available. Anybody who thinks I ought to do a video on it, let me know. But I'm not going to do a video unless I know what the interest is, because I got a bit of stick from somebody for my last one when I was talking about the megapoints decoder. Just saying that this is not railway modelling, this is too much electronics, and I will be unsubscribing. That's fair enough, and I'm happy that the guy told me that. I did point out to him that railway modelling was a very wide topic, and would he be upset if somebody did a whole series of programs on how I built my baseboards out of wood, or you need to do research, you need to understand railway practice. Well, you can understand it. You need to do electrics, etc. We had a little conversation, and I think he got my point, and I get his point. But what I say to that is that not every video I do will be suitable for everybody. So if you're not interested in it, then by all means leave me a comment to say this really isn't of any interest to me, but I prefer videos of so and so. That's absolutely fine. I'd rather you do that than just leave a dislike. You can leave a dislike as well as leaving me a comment. I don't mind dislikes, but dislikes that are completely anonymous don't get anyone anywhere, because they don't tell us what you dislike. And to be honest, by disliking a video, you don't put any strain on us as YouTube creators, because YouTube treat likes and dislikes as the same thing. They provoke to reaction, and that's all YouTube want from a video. The more reaction it provokes, the more interest it was showed. So don't think that dislikes mean that YouTube will throw us out. They're just as happy as they are with likes. Anyway, that's what else I've been doing. I've also started tearing down, as I've said, I think, Inglethwaite, and I'll show you some more on Inglethwaite's new baseboards when I start building them. So I think that's it for this video. I have waffled on for a long time, but there was a lot to get through. Just a reminder about the CTA and its price. Please leave a comment whether you think it's too expensive, the right price, or could be more expensive, whether you would buy it if you were in the market. I'm not looking for people pledging their support. I'm simply looking for a consensus of opinion. And the more people that comment and give me that opinion, the better Hugo and I will be placed to decide whether we're going to make it available on Shapeways or not. There will be a tiny profit in that £15 for Hugo, but it will be tiny. He will need to get a lot of them made by Shapeways before he makes a profit, I can tell you, over the amount of time he spent building it. So I'm going to leave you now, say thanks for watching, don't forget to comment, and I'll be back as soon as I can. Bye.